Hello and welcome back everyone to yet another lesson in web development. Given our previous lesson where we've covered the basics in the SQL syntax, today is going to be our first deep dive into SQL. And in today's lesson, we are going to learn how to create tables. With that said, let's have a look at the objectives for today's lesson. First, we'll explore DDL statements in greater detail, as this is going to be a big part of our practical demonstration in today's lesson. Then we'll move on to reviewing SQL data types and the various constraints that we can apply to our database. And then lastly, we'll have a practical demonstration where we'll create our first table using the SQL syntax. Now, we've covered DDL statements in our previous lesson, otherwise known as data definition language. But this is important for today's lesson because we are actually going to be using DDL statements. So let's revisit this topic. First, DDL statements are used to manipulate schema objects. Schema objects include things such as tables and views, for example. We can also use DDL statements to revoke or permit database privileges. This allows us to grant users specific access to specific parts of our database, or even revoke that access. And then lastly, some examples of these commands include create, alter, and drop. So let's explore some of these common DDL statements or commands in a little bit of detail. First, we have create. Now, create allows us to create a schema object from scratch. And this again includes things such as views and tables. In today's lesson, we're going to create our very first table so that we can add data to that table in our next lesson. We can also alter specific characteristics of our schema objects. If we think of a table tends to have a bunch of columns. The alter statement allows us to alter column names, for example. And then lastly, the drop statement is somewhat self-explanatory. In the event that we want to delete a table or a view or a schema object, we use the drop command. Wonderful. Now, what about SQL data types? Well, there are common SQL data types that we'll often use when creating a database. This includes things such as varchar, which is essentially a string of characters. Sometimes people refer to this as varchar as well. We also have int, which refers to integers or whole numbers. We can also add decimal numbers to our database, or we can use the specific data type within our database. And this varies from an integer in that these kind of numbers have decimal points. And then lastly, we often work with the date data type. Excellent. Now let's move on to SQL constraints. What exactly are SQL constraints? Well, first of all, SQL constraints are used to enforce rules for data stored in a table or within a database. This ensures data integrity and provides us with reliable data moving forward in the event that we ever want to query that data. And then lastly, we enforce constraints on a column level or even a table level. And here are some common SQL constraints that we will use going forward in our upcoming lessons. First, we have the primary key. And a primary key is a unique identifier associated with a record. Think of this much like your fingerprint. No one else in the world has your specific fingerprint. We also have a foreign key, and a foreign key is a key that allows you to associate a primary key value with different records that can hold multiple foreign keys. This will all make sense once we get into the meat of SQL. Now, the best way to differentiate between a primary key and a foreign key is by thinking of this analogy. Every item in a store, for example, might have a specific SKU, which is a serial number associated with that specific product that is a unique identifier to that product. Whereas with a foreign key, you can think of as a category. You might have several products under a given category, your category here being your foreign key, whereas with a primary key, it varies in that it is a unique identifier. We also have not null, which is a very, very important constraint in the event that you need a specific piece of data within a given record. This implies that when a user creates a new record, a specific field cannot be null, and we will be using this quite often. And then lastly, we have unique, which is pretty similar to the primary key constraint, but we tend to use this for fields such as email addresses, for example, because if you think about it, logically speaking, not everyone in the world can have the same email address. Wonderful. Now that we've discussed the details of some of the important concepts that we are going to use in today's tutorial, let's dive right in and let's get started with our demo. Now, before we get started with the demo, I think it's quite important that I take a moment to explain how we are going to tackle this demo in terms of the workflow and the logic here. So the first thing I'm going to do is I'm going to boot up my Atom IDE, our favorite IDE when it comes to developing web applications. And then you also want to be certain that you have your XAMPP server running. So you could either activate it over here, or you could simply just run a search on XAMPP, and this should bring up your control panel. So once your control panel has loaded, make sure that you've started both the Apache service as well as the MySQL service. In my case, both of them are activated, so you should see start on both of these buttons if they are not yet activated. Once they are activated, you'll notice that each of them will be highlighted in green. So now that my XAMPP server is running, I can head over to my browser and simply log into my localhost PHP admin. And this is how we're going to work in terms of the flow. So we'll be writing our code over here in our IDE, and then we'll simply just port that code over to our SQL over here. But before we do that, I'm actually going to create a brand new database from scratch. So I'll simply click on new. I'll call this my_db. You can name this whatever you want. And then I'll simply click on create over here. And now I've got an empty database. So I want to make sure that I'm within the SQL query tab, and I'll leave it at here for now. Let's hop over to Atom and let's start writing our code. Now in this demonstration, I'm actually going to create two tables with two separate blocks of code. And the rationale behind this demonstration is that imagine you were starting a simple e-commerce store, for example, and you had to create a database to store your product data. In this case, I'm going to have a products table as well as a categories table. First, I'll start off with the categories table. So the first line of code is simply going to be drop table if exists. And I'm going to use backticks over here. And I'm going to call this table categories. Now, I also want to save this, but before I do, let's just close this off. And I'm simply going to save this as an SQL file. And to save this file, I'm simply going to head over to File, and I'll say Save As. So let's just reopen File, Save As, and then I'm simply going to name this L2. I also want to make sure that I have the word SQL appended to the end so that this is treated as a SQL file. So if I save this now, my text is highlighted and I can actually see the various keywords. So this first line of code essentially says that if the categories table exists already, then drop that table and recreate it is what I'm going to do next. But we know this table doesn't exist because we just created the database. But then again, I wanted to also show you how the drop statement works. So the next thing I'm going to do is actually create this table. So I'll say create table. These are the keywords used to create a table. I'll use the backticks again over here. And then I'll simply say categories. And then I need to open up a set of parentheses over here. So this statement over here, this line of code simply says create the table and name it categories. And then in our parentheses, this is where we're going to create the structure of our table, if you will. So on a new line over here, I'm going to use backticks again. And then I'm simply going to create the first column in my table, and that's going to be category code. I'll use camel case. And then I need to specify the data type. Now remember, there are various data types that we can actually use in SQL. In this case, I'm simply going to go with int. You could also have this in uppercase. It's all the same. So I want to then specify how many numbers can exist in this integer. Well, I'm going to go with 10. That means I can have 10 different numerical characters within this category code. And then I'm going to enforce a constraint over here and say that this field cannot be null. So when the user creates a new row or a piece of data in categories, this field cannot be null. And then next I'm going to create another field over here, or another column rather, and I'm going to call this one category name. So category name, and this is going to be of type varchar, in other words a string, and this is going to consist of a maximum of 50 characters. This too will be not null. Excellent. So lastly, for this table, I'm going to create another column, and I'm going to call this category description, like that. And this is going to be of type varchar as well. And this will require a maximum of 120 characters. And then I'll also say that this is a not null field. Therefore, data must be supplied. And then the last thing I'm going to do is I'm going to enforce a constraint on one of my columns, and that is going to be category code. So on a new line over here, I'm simply going to write the word primary key. And this basically implies that one of these columns are going to be my primary key. So open backticks, and the one that I want to enforce this constraint on is my category code. And the idea behind this is that every category can have a specific unique identifier associated with it. In this case, that's going to be an integer of a maximum of 10 digits. And then I'll simply just close this off over here and bring all of this up. I'll save this file, and now we'll move on to our next table, and that's going to be our products table. So on a new line over here, now I'm going to use the exact same statement that I used on top over here to make sure that if the table already exists, I want to drop it. You don't always have to run this statement, but this is just a way of being cautious. So I'll simply replace this with a string or a name of products, and then I'm going to create this table if it does not exist. So create table, much like before, and this table is going to be called products. And then I'm going to open up my parentheses and start building this table. So the first one is going to be of product code type. So product code, much like a category can have a unique code, a product can also have a unique code. This is going to be of type integer, which consists of 11 digits maximum. This too will be not null. And then I'll move on to the next line, and then I'll add my product name, and this is going to be of type varchar and consists of 50 characters. This will be of not null. Then next I'm going to add my product price. So product price. And then I'm simply going to give this an integer value. You could use decimal here, but I'm trying to keep things simple. So this is going to be a maximum integer of 8 digits. And this too will be of not null. And then I'm going to add a category code. And this category code is going to be a foreign key in this table, but a primary key in the categories table over here. So open up my backticks, and then I'll say category code, and I'll show you how we enforce this constraint in a second. This is going to be of integer type, and this is going to be 10 not null. Now, one important thing to take note of here is that if I'm enforcing this as a foreign key in my products table and a primary key in my categories table, the data types need to match as well. Okay, of integer type 10 or amount of 10, the same has to be applied in my products table. So now I can go in and enforce my constraints. So the first one is going to be a primary key constraint on my product. Let's actually add backticks in over here. Product code. And then I need to enforce my foreign key constraint. Now this one is slightly more complex. I'm going to start with the word key over here, and then I'm going to say my categories code, or my category code, is the one that I'm targeting. Open up parentheses over here. I'll say category code. And then I'm simply pointing to my category code over here, and then I'm going to enforce that constraint now. So I'll use the keyword constraint. And then let's maybe just put this on a new line as well. And then I'm going to open up some backticks, and then I'm going to give this constraint a name so we have a reference to it. And this is going to be products underscore F key for foreign key. And then I'm going to use reserved words once again, keywords, and I'll say this is of foreign key type. Excellent. So again, open up parentheses over here. And then I'm going to say that I'm targeting the category code, and I'm going to use the keyword references. Which table exactly? And that is going to be my categories table. And then once again, I'll supply the primary key, which is going to be category code. Excellent. And then we can close this off at the bottom over here. So we've done all the legwork in terms of creating our tables. This part might seem a bit tricky, but it'll explain what's happening here as we go through the example. Essentially, we created a primary key of product code. We also created a foreign key, which is the category code over here. And my foreign key is a foreign key in this table, but a primary key in this table. That's the biggest takeaways over here. And we use primary and foreign keys to build relationships between our different tables in the event that we want to query data and retrieve data from more than one table. So I'll save this up. And now we can actually take our code and use it inside of our PHP admin. So I'm actually going to show you something that is quite important and something you probably should take note of. I'm first going to create the products table, but I'm going to do so with intention so that this code can actually fail. So I'll copy this, head back over, and in my SQL environment, I want to make sure that I'm hovering over the database that I want to create this table within. I'll simply just paste this code over here, and we do have one error, that is a typo over here. And if I run this code now, I'm going to get an error. And the reason I'm getting this error is because it's looking for a foreign key, but it doesn't exist. This foreign key does not exist. The reason for this is because I have to create the categories table first. Remember, this foreign key is being carried over from my categories table. But the reason the error is being thrown is because SQL is saying, hey, where is this category code foreign key or this primary key from the other table? I can't find it, so therefore I can't create the table. So I'll actually just remove all of this, head back over to my code, just clean up the typo we had earlier. And now I'm simply going to copy all of this. That's my categories table. So I'll insert that over here. And now if I click go, okay, everything has successfully been created. So now if I take that exact same code and I copy this table over here, or this code over here for my products table, and if I show query box, I can just erase all of this, paste the code, and if I click go now, okay, then the code is successfully executed. And we can actually see over here that the tables have indeed been created. And these are the columns associated with that table. You'll notice over here, category code is a primary key that is shown to you or illustrated to you by this key over here. And then in our products table, we also have a primary key of product code and all the other columns that we created alongside all of that. Excellent. So now we've officially created our first couple of tables. But what happens in the event that we forgot some column and we actually want to add a new column? This happens quite often. So let's see how we can resolve this issue. So now I'm going to head back over to Atom, and I'm going to add a new column to my products table, one that currently does not exist. So here at the bottom, I'm simply going to write an alter statement. And if you remember correctly, an alter statement allows us to update or change our schema objects. So I'll simply say alter table. And the table that I'm targeting over here is going to be products. And then I'm going to use the add statement. I'll say add product description. And I'm going to say this is of varchar. And this is going to consist of a maximum of 120 characters, and this is also going to be of not null. Excellent. And there we go. So now I'm simply going to take these two lines over here, and you'll notice that product description currently does not exist in my products table. So I'm going to be adding this, okay, with the constraints and the data types that I've given it. So I'm going to copy this over here and simply head back over to my environment, and I'll go to SQL once again. And now if I paste this and I run this code, you'll notice that I have a success message. And if I review my tables now, you'll see that I actually have product description, which was added over here. Wonderful. And that brings us to the end of this tutorial. In our next lesson, we're actually going to start inserting data into this table. So for all of that and more, I'll see you in the next lesson. Cheers.